In this video, we're going to continue our discussion about STL, the C++ standard library. STL, of course, stands for Standard Template Library, and we will see more examples of containers, iterators, and algorithms. So this is the presentation that we're going to use today. So there's a variety of different types of containers in the library. Sequence containers contain the elements in predictable order. For example, string stores characters in the order in which we populate the string. Same thing with vector. A vector is also known as dynamic array, but basically it does not do anything to reorganize the sequence. It just maintains the sequence. A list is just a vector, but it maintains pointers between the nodes. Unless you know why you need to use the list, I recommend that you always use vector as your first choice. Queue allows to insert elements at one side and retrieve elements on the other side. So this allows us to create a queue of elements, and of course the queue is basically just a sequence, but restricts its access at two sides. Stack is a container that allows insertion and the removal of elements only at the top of the stack, basically at one end of the container. By the way, vector can be used just like a stack because it has pushback and popback operations, which allow you to do exactly the same things, essentially using vector as a stack. And stack is most likely in your standard library is just an adapter of a vector, of an underlying vector. Priority queue actually accepts individual elements with assigned priority, so items may be sorted in this priority queue according to their priority. Bitset is a special type of container that simply saves space. It's like a container of Boolean values true and false, but instead of storing Boolean data type, it maps its elements to a sequence of integers with just using single bit representing a corresponding true or false. So the sequence really sort of like using a predictable order of elements, and that order is exactly the order in which the elements were inserted. Associative containers, on the other hand, may resort the order, may reorganize the order. For example, a map stores keys of elements and always maintains a sorted order of the key, but at the same time provides quick access to an element based on the key. A set is also an equivalent of a tree. The set is basically maintains unique set of elements. So for example, if you want to store values between 0 and 10 in a set, and you insert the same element multiple times, only one copy of it will be retained, and set is also ordered. Multi-set allows multiple instances of the same element, but still retains the sorted order of the container. Same thing with multi-map. So we're going to take a look at examples of some of these containers in this presentation. So the stack, this is a little demo about the use of stack. And why would you want to have a stack? Well, sometimes you could be processing some information, for instance, that's coming from a file or from some other data source. And as you encounter certain elements of data, you may want to store them temporarily somewhere. So the idea is that you create a stack like this, right? So you declare a stack. This stack is parameterized to store, it's a stack of integers, so it stores integers. And then you can just simply use the push member function on the stack, and every time you push a value, it will be stored in a container. Then there will be a time when you want to retrieve all of the elements, and you can just use the pop function to retrieve the elements back. Actually, top allows you to access the top of the stack, and pop simply removes the item from the stack. There is also a clear member function which removes all of the elements. So anyway, so stack can be used when you need some kind of temporary storage for multiple values. If you need temporary storage for one value, you can just create one temporary variable, like local variable. But if you don't know how many of the temporary values your algorithm may be able to produce, then the stack would be your choice. So in this example, we have a stack named as t, and we push the value 100. The size returns the size of the stack. Initially, this stack would be empty. This stack right now with the value 100 should equal 1. So assert macro simply verifies that this condition is true, and if it's not true, it will generate a runtime error. Okay, so then the top, as I mentioned earlier, provides access. The top member function provides access to the top of the stack. So this is the last element that we pushed. So we're expecting this to be the value at the top of the stack. And the stack really restricts access only to the top element. So basically, in terms of the data access, this is your data access. This includes mutable access as well. If you'd like to replace the value at the top of the stack with something else, it's not a problem. You can do that. You can just simply use this because it returns a mutable reference to the value on top. So now 100 will be replaced with new value 456. And then you can once again observe that we're trying to verify this condition by comparing the new value at the top with 456. Pop removes the element from the top of the stack, and if container once again becomes empty because we just pushed one value, so then you can check whether the stack is empty. So at this stage, I'm expecting that the stack should be empty, and that's a quick demonstration of the stack. The stack exists in the stack standard library header.